Hello guys, I'm very glad and excited that we are finally in that lesson 4. In any binary fission, the one parent cell undergoes into division, cell division, which is relatively equal to daughter cells. And the two daughter cells will, after a period of, let's say, generation time, after a period of maturation, will go into another division to have another two parent cell. So in that order, it keeps going and keep going and keep going until you get to the end of the exponential phase, and then you start your calculation. And in each of every division between the parent cell and the daughter cell, there is what two parameters you must know, which is the generation time and generation level. For each level, cell cycle division, we have a generation level, and for each of that to happen, it happens within a generation time. And within this, a cell can go into different series number of generation level, and each generation level indicate a generation cycle, a cell division cycle, and each of them happens within over time. Generation time is the same thing in every cycle of division. Generation time, that's why the GT here and the GT here are the same. So this generation time is also known as the word doubling time. Generation time is also known as the word doubling time. That is the time taken for each division to occur. While the generation level, which is indicated as GN or N, small n, is the generation level. That means the number of division cycles that have occurred within the life cycle of that growth phase. And when we indicated this B requires or is connotes initial microbial load or cell population prior the division from the point of your assessment, from the time you want to assess. That is what you call initial microbial load or cell population prior the division. Why the big B connotes the final microbial load or cell population after the number of division of cells you must have taken. So at the point of your measurement, from the starting point to the ending point of where you want to measure, or the incubation time you have already taken, or the microbial system you have already measured, so within this time is what you call what is there before and what is there after the cell division. Then you can be able to calculate the number of generation level that has occurred, and you can also be able to calculate the generation time. Having said that, then let's look into the basic equation and relationship of this parameter. Like I told you in the exponential phase, the relationship between the initial and the final microbial load after cell division is exponential growth of 2 raised to power n. That means from this, one cell will initiate into 2, it divides into 2. The number of division represents this n. That gives us equation 1. However, this equation 1 is in exponential form, and it will be very difficult for us to manipulate some of the parameters at this exponential level. So we intend to be able to break this equation down, but let's take another basic equation before the equation 1 is equation 2, which is GT. Generation time is equivalent to the total time elapsed in the total division of your assessment or microbial activity measurement over the generation level, the number of cell division that has occurred. So that gave us to equation 2. Having said that, let's move to the next slide. The next slide says, in this equation 1, the equation 1 is so difficult at the exponential level, it has to be transformed into a linear equation. And for you to transform it into a linear equation for easy calculation, you have to put it in logarithm function. So now when you fix this exponential equation 1 into logarithm, by the law of logarithm, you say log b, anything in the right hand side will be done to the left hand side. Log b, this will go down. Then you have a linear equation of log b, big B equals to log small b plus log 2n. Following the still rule of logarithm, for you to get to the simplest form, you now say log b can be this 2 exponential could be this exponential could now move down to this point, becoming a division by the law of reducing exponential with logarithm function. You have this, then the equation still stands. Then you still want to make n the subject formula, then you move this small b from the side of the equation over the other side, and once it's moving, it changes to negative. Therefore you have log big B minus log small b equals to n log 2. you make it simplified equation. Say logarithm by the law of logarithm of minus to division or division to minus. Anything logarithm big B minus small b, putting it into 1 as a division becomes logarithm big B divided by logarithm small b. All is equals to n logarithm 2. There, the right hand side is the left hand side are equal, so you can easily or comfortably swap the places. That means n2 log 2, n log 2 coming over to the left hand side, while logarithm b over small b will come over to the right hand side, so that you can be able to make the subject formula. When you make this n subject formula, that becomes anything log 2 will divide the two sides of the equation. When log big B, n will now be equals to log big B over small b divided by log 2 equals to the same thing. That will give you log big B small b all over the logarithm. Simplify this so that you can simplify the equation. Log 2 is equivalent to 0.310. So you have this. Then you now come down to simplify the equation further. Then you have n is equals to logarithm big B over small b all over 1 times 1 over 3 this. This is still the same thing. You've just expanded this one in order to make it simpler, so that when you now divide this whole logarithm big B small b divided by 1 is still the same thing, times 1 inverse of 0.3010 is equivalent to 3.3. You can punch that to your calculator and that will give you the right answer. So when you now multiply logarithm big B and small b times 3.3, that will simplify the equation to n is equals to logarithm 3.3. N is equals to 3.3 times logarithm big B over small b. That gives us equation 3. All we did in this logarithm function is to reduce the equation 1 into equation 3 for easy calculation and manipulation of the figure. So having said that, let's quickly go to one simple example. One simple example is going by exercise 1. The exercise 1 that says if you have 10 microbial cells multiplied into a population of 500 cells in 2 hours, calculate the following: A, generation level that has occurred. 2, the generation time. Then the solution quickly goes, you extract the parameter that is given in the equation, the question as the case may be. You have the small b, which initial microbial load is 10. You have the final one, which multiplies to 500 cells. The total time overlap is 2 hours. Then they are looking for generation time and generation level. Then quickly you now move into the answers. You now say, note, only equation 3 is appropriate for this parameter above. It's only equation 3 that can easily go into this parameter above in order for you to solve the equation. The first you need to do is, you now say n, you are looking for generation level n. N will be given to 3.3 times logarithm. This is equation 3. 3.3 logarithm big B small b is equivalent to 3.3 logarithm 500 over 10. That will also give you 3.3 logarithm 50 is equivalent to 3.3. When you now find the logarithm of 50, that will give you 1.6989 in bracket. Then when you open the bracket, the rule of BODMAS, everything in bracket must go before anything outside the bracket. When you now open the bracket, saying 3.3 times 1.6989 will give you equivalent of 5.6067, which is approximately 6 generation level. That is 6 division has occurred within 12 hours. Then for you to solve the fourth equation for the second question, which is generation time, you now use your answer in the first equation, just generation level, to fix it into equation 1, equation 2, which will give you generation time is given as T over Gn. Then let's go back. Then you now say Gt is equals to T over N. Remember equation 2 above, which we have just shown. You now say Gt, generation time, is equals to 2 hours over, you use the actual value, not the approximated value, please, so that it will have the actual result. Then you now say 2 hours divided by 5.6067, which is equivalent to, you convert it to 2 minutes. 2 times 60 minutes divided by 5.6067. That will give you approximately 120 minutes divided by 5.6067. When you do the arithmetic calculation, you have 21.40 minutes, which is approximately 21 minutes. This is exercise 2. You have, if the question 2 reads this way: you have a bottle of yogurt with an initial microbial load of 2.5 million cells, that is equivalent to 2.5 times 10 raised power 6 cells. Full stop. These microbes multiplied with a generation time of 45 minutes. After some time, the microbial population has grown to 7.5 billion cells, which is equivalent to 7.5 times 10 raised power 9 cell. Use the data to determine the following. A. Calculate the generation level, that is number of generation that occur during the microbial growth process. B. Based on your generation time, calculate the total time it took for this growth to happen. C. Provide an explanation of how this microbial population multiplied in the yogurt over time. D. Discuss the potential factors that could influence the growth rate of microbes in dairy products like yogurt. Okay, the first two questions which we are more interested in the calculation is given in this solution here. First of all, anytime you have this kind of question, extract the parameters for you to know the best equation, either equation 1, equation 2, or equation 3 that is the best suited for this example. When we extract the values, you have initial microbial load is 2.5 times 10 raised to the power 6 cells. Final microbial load is 7.5 times 10 raised to the power 9 cells. Then you have the GT, which is given here. Then you also get the GN, generation level, unknown, and the total time, unknown. Then from the equation, you can know that the best option for you to start with is equation 3, which is in the linear form. You see n is equal to 3.3 times logarithm big B over small b. Then you also go into your normal arithmetic or mathematical calculations. You say 3.3 logarithm in parentheses big B 7.5 times 10 raised to the power 9 and small b is 2.5 times 10 raised to the power 6. So when you simplify the equation further, you expand the standard form into real numbers. So when you have it in real numbers the way they are supposed to be, then you cancel out zeros in the process. At the end of the day, you have 75,000 divided by 25. So when you simplify it further, 25 into 75,000 will give you 3,000. So you now still have 3.3 times logarithm 3,000. So when you now punch the logarithm of 3,000, that will give you 3.47712. When you multiply it now with 3.3, your n generation level now gives you approximately 11.74744 generation cycle, which is in the whole number. We can round it up into 12 generation division that has occurred in this time space. Now the question B says, based on the generation time, calculate the total time it took for this growth to happen. Now you are no longer looking for generation time. You are now looking for the overall time. So you now say time is because how long taking for the microbial growth to occur. Then you now say go to equation 2. It says generation time is equals to T over N. Where you are looking for T, you make T subject formula. T will now be equals to generation times time generation level, which is equivalent to generation time is already given in 45 minutes. 45 times you use the actual value of generation level you determine in the first equation. Then when you multiply it, you will have overall of 516.348 minutes. And this is not usually left this way. It's usually converted into hours. So when you convert it into hours, you have 8 hours 36 minutes. So the process of conversion is by dividing the 516.348 by 60. That will give you 8.6 hours. So when you convert this 0.6 hours, multiply it by 60, then there you have 36. So this is how we got to this point of 8 hours 36 minutes. Thank you. We'll end the video here, so I will continue with another example.